When we last talked, we were exploring how to use an algorithm to multiply mixed numbers, and we had just started to talk about that. You can use the standard algorithm to multiply a whole number and a mixed number and a fraction less than one, or two mixed numbers. And that's what we're going to be focusing on in this part of the lesson. So here we have a recipe. This is a recipe for some Hawaiian trail mix. The teachers at Riverside Middle School decide to make the trail mix for an upcoming field trip. Miss Hadley shares her Hawaiian trail mix recipe extravaganza with the other teachers, and this shows the recipe for one batch. You can see it's enough there to feed 12 people. Now, Megan and CJ determined the number of cups of almonds that it would take to make 3 batches. I want you to pause the video and talk with your partner. Megan and CJ agree. They got the same answer. But how is CJ's strategy different than Megan's? What did they do differently? So what do you think? When you look at their work, which one do you think would be faster? Is one of them a little bit easier to do in your head than the other? They're both correct routes to the same answer. You can do whichever way you prefer. CJ recognized that a 3 in the numerator and the 3 in the denominator cancel each other out. 3 divided by 3 is 1. So he knew that he could cancel those out and get 7 over 1, or just 7. It's kind of a little shortcut that he used because he understood that when you multiply both the numerator and the denominator by the same value, that's really like multiplying by 1. All right, so now let's talk about the number of cups each ingredient will take to make 4.5 batches. We'll do one example together, and then I'll give you some time to work on this on your own. So we need 4.5 batches. How much corn syrup do we need? How many sunflower seeds do we need? And pumpkin seeds. We're going to do the corn syrup together. Actually, hang on. Let's do the sunflower seeds together. So we're going to do the sunflower seeds together. We need to make 4.5 batches. And for the sunflower seeds, one batch would be 1 1/3. So we need to multiply 4 1/2 times 1 1/3. So let's talk about how to do this. Before we get started, we need to change both of these mixed fractions, these mixed numbers, into improper fractions. So first, let's do 4 1/2. 4 times 2 plus 1. That'll be our new numerator. And our new denominator will be 2. Now 1 1/3. 1 times 3 plus 1. And our denominator is 3. 4 times 2 is 8, and 8 plus 1 is 9. This is 9 halves. 1 times 3 is 3, and 3 plus 1 is 4. 1 1/3 is the same thing as 4/3. So what we're really multiplying together here is 9 halves times 4/3. We're going to multiply numerator times numerator and denominator times denominator. Now, do you see a way that we could make this easier? I do. Now, you don't have to do this, but for a lot of us, it'll make our multiplication easier. 4 and 2 are both divisible by 2. 4 divided by 2 is 2, and 2 divided by 2 is 1. If you want, you can simplify that way. You can divide both of those by 2. You could also divide the 9 and the 3 by 3, changing them to 3 and 1. Now, some people think that's great, and they can say, oh, wow, 3 times 2, that's 6. Some people think this is confusing. If you think this is confusing, then don't you worry about a thing. You do not have to notice your factors like that. You can just multiply straight across, and you will get the right answer that way. 9 times 4 is 36. 2 times 3 is 6. 36 over 6 is 6. See? We got 6 simplifying, and we got 6 not simplifying. Perfectly fine whichever way you prefer. So we are going to need 6 cups of sunflower seeds to make 4.5 batches. Now what I want you to do is to work with your partner. We're going to set a timer for 5 minutes, and you are going to do the corn syrup and the pumpkin seeds. Your first step is going to be to get your values from your recipe. You're going to change those values from mixed numbers to improper fractions, and then you're going to multiply. Numerator times numerator, denominator times denominator. Be sure that your final answer is simplified. All right, pause that video, set the timer, and work for 5 minutes with your partner. Nice work. Now that you have built up a little bit of confidence, I want you to try some problem solving on your own. So let's give it a shot. All right, I am going to model 2 of these problems. I'm going to do letter A and letter F. You are going to get to do the rest of these problems on your own. Let's do A first. We've talked a little bit about how to write mixed numbers as improper fractions. We have 2 times 2 plus 1 over 2. We have 3 times 5 plus 2 over 5. Let's see. 2 times 2 is 4. 4 plus 1 is 5. 3 times 5 is 15. 15 plus 2 is 17. So those are the 2 fractions that we need to multiply together. We need to multiply 5 halves times 17 fifths. And I see a 5 on the top and a 5 on the bottom. Those will cancel out. That's going to leave me with 17 over 2. 17 over 2, let's just go ahead and divide that. 2 goes into 17 8 times. That's 8.5. So that's my answer to part A. And the process that I used was I rewrote my values as improper fractions. I multiplied numerator times numerator and denominator times denominator. And then I simplified and rewrote it as a mixed number. Choice F is a little bit different, and the reason is because we're multiplying a mixed number by a whole number. This is actually easier. Here's why. We need to rewrite 2 and 5/8 as an improper fraction. That'll be 2 times 8 plus 5 over 8. See, that's going to be 2 times 8 is 16. 16 plus 5 is 21. So we've rewritten that one as 21 over 8. And here's why this is easier. To write 3 as a fraction, we just write 3 over 1. So what we're multiplying here is 21 over 8 times 3 over 1. 21 times 3 and 8 times 1. 21 times 3 is 63 and 8 times 1 is 8. I don't really want to leave it like that. I would rather have a mixed number. There's nothing wrong with an improper fraction. Don't get me wrong. But I'm going to go ahead and see how many times 8 goes into 63. 8 times 7 is 56. And then I have 7 left over. So this will be 7 and 7/8. The same process, just a little bit easier because I didn't have to write 3 as an improper fraction. I just wrote 3 over 1. Now let's talk about what you're going to do. On your own, I want you to spend a good chunk of time doing this. It says 3 minutes here. That's not enough time. We need 12 minutes. I want you to do B, C, D, and E. You can do this. Use the other problems as a guide. You're going to use this same steps every time. You're going to go from a mixed number to improper. You're going to multiply the numerator times the numerator, and then the denominator times the denominator. And then you're going to simplify. That's it. Mixed to improper, top times top, bottom times bottom, simplify. That's all you got to do when you've got 4 problems to take a look at. Pause the video and hit play when you're ready to move on to the next task. All right, you've hit play, which means you're ready to move on. Check your work, see if you got the right answers. See why or why not you did not get the right answers. And I want you to just talk with a partner about anything that you do not understand. So check your work. And then once everybody's had time to check your work, pause the video. And then I want you to check with your partner and be sure they know how to do each of these problems. I want you to be sure you know how to do each of these problems. Don't hit play until everybody knows how to do B, C, D, and E. And remember, you're following that 3-step process. Change the mixed numbers to improper fractions. Multiply, numerator times numerator, denominator times denominator. Simplify. 1, 2, 3, and you're done. All right. If you've hit play, that means you're ready for the demonstration of learning. This demonstration of learning will be done with a group. And here's what you're going to do. You're going to look back at all of the factors and products from this lesson, and you're going to see what generalizations you can make about fraction multiplication. And your task as a group, you may not agree, is are these statements always true, sometimes true, or never true? There's a correct answer to each of these questions, and you have to decide as a group. Is this always true? Is this sometimes true? Or is this never true? You must provide examples to make your case. After doing this, you're going to describe the algorithm for multiplying any two fractions or any two mixed numbers. Once you have had time to look at this, we are going to have a bit of a debate as a class. We're going to talk about number one, and we're going to see, what do you guys think? Is it always, is it sometimes, or never? Be prepared to justify your opinion.